Well, with that, I definitely want to thank IssueTrack for hosting now our second meetup of DevSecCon. And with that, we'll jump into it here. But just for housekeeping, I'll mention now that so our aim, this is only the second one, but our aim is to meet on the fourth Wednesday every other month. I thought maybe I'd do every month at first, but we're going to start slow. But in June, that would usually be the month that we would skip. We have our big DevSecCon conference. It's 100% online. There's a really good slate of speakers. I'll make sure to put up the link to that at the end, but that'll be it's either the 13th and the 14th or the 14th and the 15th of June. We'll get that sorted out at the end. And then I'm definitely looking for speakers for July and beyond. So if you are interested in speaking or you know of anybody that is interested, we had a really good one for our first one. A couple of you were here for sure. Were you here? No? All right. But that was
social engineering.
Yeah, Branson, and boy, that was fun. So so for July we got a little bit of runway. But if you are interested in speaking or know of anybody who might be interested, just hit me up through the meetup page is probably the easiest way. But also Twitter, LinkedIn, whatever. All right, so what I'm going to do here, I think, is I'm going to do this, which gives us a little more landscape. Now, who's ever connected remotely, hi, everybody who's connected remotely, they can still hear us. So we're still connected to the live stream, but we're just not seeing the video at the moment. I can add that back in at some other point. So tonight I thought I'd present this talk I have done before called Blasting Browser Security. And there's one element of it that you're not going to get tonight, which is when I first did this talk, it was for Okta's security conference. And in that talk, I live submitted a browser extension to Firefox and Google to see how quickly it could get through their process, or if it would get through that process. I didn't know if it would. And I purposely made the browser extension request all of the permissions that it could possibly request. So monitoring your web traffic, writing to your local storage, I requested all the permissions to see what kind of scrutiny it would get, whether or not it would get through the store. And I was hoping for something really dramatic, like it would get listed while I was doing the talk. It ended up taking a few hours, so it didn't happen live. But the punchline is this browser extension that I'm going to demonstrate to you is live on both the Chrome Web Store and the Mozilla add-on store. And I'll give you a little bit of background on myself, but being a chaotic neutral in Dungeons and Dragons, like I like to cause mischief, but not really do any harm. So I made sure that the extension that I published demonstrably could do bad things. Like it's provable that it could do bad things, but it doesn't actually do bad things. So it kind of walked that line a little bit, and it sailed through both whatever the internal process is for review. It got listed same day, within a couple of hours. So that's the big punchline. But let's see how we get there. Oh, and there was one thing I wanted to make sure I had my little clicker thing here. Bear with me one sec, because sometimes I need to zoom in, and this is handy for doing that. What do I want to do? I want to launch the clicker software. Here we go. So did I do it? Yes, I did it. Okay. So here we go. Should be able to get a zoomer. Nice. All right. So just a little bit about me. I did a little bit of an introduction, but aside from running our DevSecOps acceleration team on our developer relations team, I contribute to open source projects. The one I have pictured here is Java JSON Web Token. If you're familiar with JWTs or JSON Web Tokens, they're awful. But I contribute to this Java project, and it's the most starred Java project, the most starred JWT project on GitHub. So I'm kind of proud of that. I haven't, it was architected and written by a former CTO of mine, Les Hazelwood. He's very big in the Java community, but I do some humble contributions to it. I also got to co-author this book just in time for this technology to be irrelevant, but still something I'm proud of. So what is a browser extension? Who here uses any browser extension of any kind? I think most of us do these days, right? The one I probably use the most is 1Password. Awesome password vault. Kind of, saved me from, I don't know any of my passwords anymore. It's great. And it works well in the browser to fill stuff in. That has broad permissions in the browser, but that's a valid use case. But pictured here is just my typical day of browser extensions. Let's see if I recognize them all. That's 1Password. This other one, the blue shield, is something that I wrote called the implicit flow detector. If anybody's familiar with OAuth or OIDC, it's a security flaw deprecated that a lot of sites still use. So it'll give you a little alert if you go to a site that's still using that, because it could leak your information. I got the eyedropper, a couple other things here. Some are common, some are not. The Vue.js browser extension is kind of nice for debugging Vue.js apps. But the point is, it's a small bit of software for customizing the web browser. And it's got these different parts that make it up. 3 primary parts, and they're all described in this manifest file. So there's a background script, and like it says, it's running in the background. It's just another JavaScript process, making your laptop as hot as the surface of the sun because it's, mining crypto or doing whatever it's doing. But that just runs in the background. Then we have pop-up scripts. That's what you see in the browser. If not all browser extensions have interactions. Some of them, their only purpose in life is to be running in the background. But if it does have any sort of UI to it, like when you click on the icon, it opens up some kind of window. That's what the pop-up script is for. And then there's a separate class of scripts called content altering scripts. And those are scripts that alter the content on the page that you're on. And there are a lot of valid use cases for this. So for instance, with 1Password, you go to a site with a username and password field, and you get the little 1Password icon in that username field or in that password field. Well, that's an effect of the content altering script part of the 1Password application. So super handy, but also, if you're not careful, can be very mischievous because like it says, it can alter the content. It could completely change the content on the page, and maybe you forget about it, or maybe it's doing other stuff than what it's claiming to. How do you really know? There was a popular browser extension that would replace the occurrence of anytime a certain person's name appeared on a website that you were browsing, it would turn it into some other name. It did that on purpose. It was a little joke extension, but maybe you forget about it, or maybe somebody else is using your computer and you have it installed there or something. So content altering scripts are very powerful, but it's one of those double-edged swords of, is the content on the page that you're looking at really the content that was delivered by whoever owns that page? If you're working with browser extensions, you get to a point where you can't be 100% confident to that. So all of these parts are described in this manifest file in different sections, and we're gonna look at each of them. But you have your background script, your content scripts, and pop-up scripts. And then one thing I'll point out here is also the permissions. And it's a little bit funny, usually an array is, just an array of elements, but the order here is significant. So the first element of this array is a permission expression that includes a protocol, a domain, and then links deeper into the site. you can see here I've requested access to everything, any protocol, any domain, any subpage or endpoint. I want the other permissions that follow apply to that pattern. And what I've asked here is for web request blocking, tabs, and storage. We'll get into more what that means, but web request blocking is particularly significant because what that allows me to do is to intercept a request, alter it in some way, and then let it continue on. That's a very powerful permission because that allows me, like, let's say there's an image on a page. Well, I could alter, with this permission, I could alter every image request and add a header to it, or add query string parameters, or add whatever to it. If it's a post, I could add additional elements to the body. So that allows us to intercept a request, alter it, and then let it continue, which is what I just pointed out there. All right, now in terms of the history of browser extensions, you may or may not have been around for the browser wars, so-called, but the short and the long of it is that browsers started introducing these things called extensions. Sometimes Mozilla sometimes they call it add-ons, sometimes they call it extensions. It gets a little confusing. For a while, Safari didn't support extensions at all. Now they do. But each browser kind of did its own thing, but they were very close. So in Google Chrome, the root was Chrome dot, and in Firefox, the root was browser dot to access these extension features. But then after that, there was a lot of overlap, and sometimes it was exact, like the one pictured on the screen. It's chrome.webrequest.onBeforeRequest or browser.webrequest.onBeforeRequest. It wasn't always an exact match like that, but in a lot of cases, it was either an overlap or a direct match. But in the bad old days, we had to have clever code bases that if we wanted to write an extension that would work in a variety of browsers, we had to have a clever code base that would detect the browser and reference different things, or maybe we just had separate code bases and some way to build and publish and try to keep common stuff together. It was kind of a pain. But then along came the browser polyfill, which is something that the Mozilla Foundation released that did us all a favor, us poor developers who just wanted to write an extension that would work in both Chrome and Mozilla. And if you're not familiar with polyfills, it's just a piece of code. It's like a shim that provides functionality. Its usual use case is to provide modern functionality on older browsers that don't support it. In this case, it's to kind of normalize the way that we reference these various functions and objects that are available for browser extensions. And the upshot of this polyfill is that it allows us to have a single code base that'll work both on Firefox and Chrome. It still won't work on Safari or Opera or old school IE. It'll work on Edge just fine, but you'll have to do the thing where you allow extensions from other stores because Microsoft has its own store, which is distinct from the Chrome web store. But if you allow extensions from outside parties, you could install something built with this browser polyfill just fine. So the big punchline here is that now with the browser polyfill, you can use browser dot as the root, whether it's going to be on Chrome or Firefox. And this little shim, this little polyfill makes it so that, in its most simplest form, it would say something like, const browser equals Chrome or something like that. But, it goes deeper than that, but it allows us to have a single code base so we can write code once and run it anywhere, which if you're familiar with Java, that was Java's big tagline for a while. I don't know if it still is. So in addition to this polyfill library file, Mozilla released a set of tools to develop, build, and deploy browser extensions called WebEx. So WebEx, I'm not, I've written a very small handful, really two browser extensions. One is the implicit flow detector, and the other is the one I'm going to demonstrate here. So I'm by no means an expert or even a good browser extension developer, but WebEx made it so that with the knowledge that I have, I could easily not only create the browser extension, but bundle it up in such a way that it was easy to publish to the Google Chrome Web Store or the Mozilla add-on store. So I appreciate that. Good open source in action, making things easier and more civilized for us developers. So every stage of the life cycle of development of a normal application is supported by WebEx in the context of browser extensions. Develop, test, build, deploy. It has, I'll show shortly, but it makes it so that if you've ever used like Webpack or any of these like modern JavaScript builders, it makes it so that you can develop and change things on the fly and have it reflected immediately in the browser, so you can develop rapidly. You don't have to like rebuild, republish locally, fire up the browser again. So a lot like Webpack will do, where you can run it locally, and then as you make changes, you can see it in the browser immediately. You can do that also with WebEx. All right, without further ado, let's look at the browser extension I created, and then we're going to kind of pull it apart. So this is the Pretty Kitty browser extension. And like I said earlier, it is live and listed in both stores. This is the Firefox add-on store. This is the Chrome Web Store. You can see in Firefox it's got one user, which is probably me. And Pretty Kitty now has 3 users. Woohoo. The other thing that I did in the spirit of being a chaotic neutral is I didn't even attempt to like promote it, publish it, say, everybody should go install this. Not that that necessarily would have, boosted the numbers by a lot anyway, but I purposely like kept it a low profile. One was because I didn't want to get it delisted. But the other was just, the spirit of this is to kind of experiment and explore with what browser extensions can get away with and come up to that point of doing something malicious without actually doing something malicious. So what is Pretty Kitty? Pretty Kitty has some cool features. Now, this is the Zoom website, nothing to do with Pretty Kitty at all, but it'll help me demonstrate some of the features. So over here, if I look at Pretty Kitty, all it does is show cat GIFs. Who doesn't love a good cat GIF? Now, it also does some other secret evil stuff behind the scenes, but I added a little bit of interface niceness to it for demonstration purposes. So I have these checkboxes, but the point kind of is I didn't have to have those checkboxes. So one is that it's going to replace all the E's on the page with E's with umlauts over them. And the other is it's going to replace all the images on the page with cat images. So let's see that in action. Do it. There we go. There's a little delay there. And I'll replace the images. And now if we look, you can see up here that anything that's a link, if there's an E in it, it's got an umlaut over it now. And then anything that is a picture has been replaced with a cat picture of the same size. It looks like it missed one, which is interesting. I don't know how that happened, but whatever. So all these pictures have been replaced. And if you notice, it's a little clever bit of coding, if I do say so myself. When it replaces an image, it replaces it with an image of the exact same size. So it doesn't like mess with the formatting of the page. So here we have another one. These cats say Zoom is probably supernatural and easy to use. More cat pictures. So you get the idea, right? So the point is, if this was advertised as a browser extension whose only purpose was to view cat GIFs, behind the scenes, it might be altering the content on the page unbeknownst to you and be up to no good. And it's even worse than that in terms of what could be happening behind the scenes. Let's take a look here. I'll zoom in on this, but I want to reload the page. And way up back at the top, what I want to draw your attention to is the request headers. Excuse me. As far as I know, there's no way to make this bigger, but I'll try to zoom in on it. You notice there's a header called x-nothing, and its value is to see here. Now that's a header that's been injected on this request. Now, even if you were a developer and even if you were paying attention to such things, this might slip by, and maybe it's injecting headers that are significant in some way to the sites that you're going to that are, you know, setting flags or changing permissions or doing weird things. The point is this extension is now injected headers. So we already know that it can replace content on the page. It's also now injected headers. Bear with me a second here. I need a throat lozenge. All right, last little bit of functionality that I want to show. I think I need to go over to here. Yes, okay. So I'm going to refresh the Zoom page once more. And the other thing I want to show you is this. Now, this is the part of the show where I'm demonstrating what I might have done if I were doing something malicious, but not actually doing it. And so what I'm doing here is I'm console logging out a change, an injected change to the request in the form of a query string parameter. So I requested zoom.us. The browser extension tacked a query string parameter on the end, but it didn't actually send that to Zoom. It console logged it out instead of sending it to Zoom. So it's like a proof of concept. It could have added query string parameters to the request, but it didn't. Now it really did add the header x nothing to see here, and so far I haven't found that breaks any websites, but I guess technically that might be just over the line because I am actually injecting that header into the real request. All right, now let's look at a couple of things here. I showed you this header. That's in just the normal developer tools that you would look at. What we're looking at here in this window, I have it like broken up into quadrants. And what we're looking at on the left-hand side is Firefox. On the right-hand side is Chrome. The top is the page. The bottom half is what looks like developer tools, the regular developer tools, but it's actually the developer tools of the browser extension. And that's slightly different than the normal developer tools. You get there in a slightly different way, but that when the browser extension does a console.log, this is where I would see it, not in the regular browser developer tools. So that's a little bit of trickiness of browser extension tools, is that the browser extension has its own console, its own network tab, and if you're interested in monitoring what the browser extension is doing as you're developing it, that's the place that you go to. By the way, I meant to mention up front, feel free to interrupt me at any time. I have no sensitivity to that. If there are questions along the way, I often forget to pause and ask if there are any questions. So just speak, totally okay.
So does the browser extension inject itself into the page and then use a document selector to actually modify the other page like a frame would or an iPhone?
Yeah, kind of like that. And we're going to look at the code in just a minute, but it's basically using the same DOM.
Okay.
It has access to the DOM of the page, and we'll see the code in just a second. But it's like, get element by tag or something is what I use to get a list of all the images and then replace them with different images, that kind of thing. So it's kind of live updating the DOM. And kind of a spoiler alert that we're going to dig into a little bit, these things are supposed to have kind of like a firewall separation from each other between the background script, the pop-up script, and the content altering script, but it's very fuzzy. They really don't have the kind of separation that they're supposed to have in practice. All right, let me look at my cheat sheet, make sure I didn't miss anything at this stage. All right, so now let's take a look at the code here. This is just Visual Studio Code. Is that big enough? Can you all see that okay? Okay, cool. So this is the project, and it's got the pieces that we discussed, and we're going to look at each of them. But here's the manifest, and this is identical to the slide I showed where I'm requesting an outrageous access to permissions. I can access your local storage. I can access all the tabs that you may or may not that you've opened. I can access non-blocking web requests for the purpose of, logging them or exfiltrating them or doing whatever I want with them. And then I can block all the requests and alter them or do something with them and then let them continue. The one drawback of the polyfill approach is you kind of have to repeat yourself in order to have it in both these places. So this is the background script and this is the content script. And in both places I have that polyfill. And you could make this a little more efficient by using Webpack or something like this. I wanted to keep it super simple. So this is just straight up vanilla JavaScript, no exotic builders or anything. So because of that, I had to repeat the use of the browser polyfill. But we have our background script, our content altering script, and then our pop-up scripts. So if we look, let's start at the beginning, which is like the stated behavior of this extension, which is, hey, we're just going to show you some cat GIFs. So I'm just using an API here called the cat API, and I guess we shouldn't be surprised that such a thing exists. But that's not the tab I want to go to. That's not what I want to do either. That's what I want to do. So it just shows cat GIFs, and it'll send you a new one every time you tell it to. So I didn't reinvent the wheel here. I'm just hooking into that. And this is the pop-up part of the extension. And one thing that's interesting about the pop-up is that by design, every time you click the icon for the browser extension, every time you click the icon, it reloads the pop-up page. It reloads popup/index.html. That's by design, but it does present some legitimate developer challenges if you want to have interaction. A lot of times there's not interaction, but for instance, I have these checkboxes and I want to maintain that state across clicks. So if I reopen it, it's reloaded popup/index.html, but it's remembered my the state that I had there. So that presents a little bit of a programming challenge, which we'll look at. But this is very straightforward HTML. Got a couple of checkboxes. We have our polyfill, and we have this other thing called support.js. And support.js is where things start to get a little interesting. And we'll work our way up from the bottom to the top. And so what it's doing when that pop-up page is loaded and support.js is loaded, it's using local storage. And this is not ordinary local storage. This is browser extension local storage. It's got its own little walled off garden, but it's getting pretty kitty settings. And then it's setting these checkboxes based on what it found in that local storage. And accessing this special local storage gets a little funky. I would call it non-intuitive. But if you notice, I'm getting this key called pretty kitty settings. And I would have expected that to return to me the value, but it actually returns to me this item, which is the key and the value. So then I have to reference it again. Now, this could 100% be, my lack of knowledge and being a novice at browser extensions, but I kind of don't think so. I think that just the way that it's stored is a little funky. So you have to do that double dip there. But then I have these two elements, these two values, replace ease and replace images, and it's going to set the checkbox accordingly. So I'm maintaining state by using browser extension local storage with the knowledge that every time I click that pretty kitty icon, it's going to reload the page. So I can't rely on the fact that I set those checkboxes before. I have to save it and retrieve it from local storage. All right, a couple other things happening here. When I have an event listener, this is like, straightforward JavaScript DOM manipulation stuff here. I'm adding a click event listener for that checkbox, and then I'm going to update settings, and it's either going to be replacing the ease with umlauts, or it's going to be replacing images. And then finally, I have the, in each case, it's calling update settings. And then update settings is manipulating that special browser extension local storage again, where it's taking the value of the checkbox, whether it's checked or unchecked, and then saving it back to the local storage. So that's all UI stuff. That's remembering what's checked, with the knowledge that it's going to reload that popover, that pop-up every time. Now, if we look at background.js, right? So that's the piece that's running in the background all the time. It could be stealing your crypto, or digging around your local storage, or making requests. You can do AJAX requests from the background process here. But what it's doing here is it's got a listener listening for changes on this browser extension local storage, and then it's reloading the tab. Now, this was a little bit of a hack. Somebody who's better at this kind of thing can, kind of live update the DOM on the fly. I chose to just save these settings and reload the page, and then just let it replace the ease and the images on reload, rather than like live changing the DOM as it went. And then this is the other tricky stuff that we were talking about, where on before send headers, this is where it's injecting that header. So it intercepts the request, it gets the details of the headers, and it's pushing this additional header into whatever headers were already there. But it has access to all the headers that were already there. So if you're logged into your bank account and you have an access token that's getting sent over as part of the request, this browser extension can intercept that and inspect it and maybe make some API calls on your behalf. I'm not trying to paint a picture of doom and gloom here, but we should be aware of what the browser extensions can do. And I'm as guilty of this as anybody else. When I install a browser extension, it gives me a list of permissions that it has. And, my eyedropper thing, I couldn't tell you that list of permissions. I don't remember. I just said, okay. But maybe in that list of permissions, it said, can read and write every request that you make. Why would the eyedropper need to do that? So, we want to try to be a little more discerning. Right. And then this is the one where it could have, this is the one that that blocks the request, gets the request. And here, if you notice, I took the URL from the request and I replaced it by adding this injected parameter to it. And if I had this uncommented, it would have impacted the actual request. But since this was being listed on the public stores, I didn't want every single request that you made to include query string parameters. So I just console logged it out. But if I uncommented this code, then it, returning an empty object basically says no op, like don't alter the request. But if I had returned this alteration, then it would have added this injected parameter to the request and gone on that way. And also, as part of this, you specify, which URLs you want this to apply to. And this also, this regex here has to match the permissions that you have. So you can go inside the permissions that you have, but you can't expand beyond them. Now, in my case, I asked for every protocol, every website, every whatever. So, so this would apply to everything. But, if you were targeting a particular domain for your browser extension, maybe you'd want to alter the request only for certain endpoints in that domain. This is where you could specify it. All right, last piece of business here is Beautify. This is the thing that actually alters the page, and it's used as in the manifest. Where is Beautify? Hold, please. Here it is. So this is the content altering script. And Beautify just accesses the DOM, and I did it in a very simple way. I'm just getting all of the anchor tags. So only anchor tags on the page are having e's replaced with umlauts. It's using a regex, which you've probably heard the age-old saying that if you have a problem and you use regular expressions for it, now you have two problems. But that's what I'm doing here. So it looks for anchor tags, and it replaces all of the e's with umlauts. And then here, there's another convenient API, cat-based API. There's probably a lot of cat-based APIs, but this one in particular, this was kind of cool because I'm iterating over the list of images on the page, and then for each image, I have that image's width and height. And this API can take width and height as a parameter, and it will return a distinct cat picture with that width and height. So that's what allowed me to replace all the images on the page without messing with the dimensions of the page. So I can go to, let's say, like 640 by 480, and it'll give me a picture exactly those dimensions. So in the code here, it's interrogating the original image and using its dimensions to replace it with a cat image of the same dimension. So that's kind of the complete tour, if you will, of our code. All right, now the way it's supposed to be is there's supposed to be this firewall, this brick wall between the background and pop-up scripts and the content scripts. And that's really for two reasons. One is if you're going to be altering content script, the original designers of this whole web browser extension architecture said, like, maybe we should keep those separate from each other, since content altering scripts are so powerful and can alter the page in a way that maybe you don't even know. Maybe we shouldn't have the background and the pop-up script like talking directly to them. The other motivation was for keeping browser extensions like separate from each other, so that you didn't have like one browser extension trying to inspect the code or pull information out from another browser extension. So that's kind of the way it's supposed to be, but really, it's very easy, as it turns out, to make these items communicate with each other, for better or worse. But the point is, the intention was that there's supposed to be a wall between them, but that wall is really porous, as it turns out. So one way that they can communicate is just through programmatic injection or seriously ugly JavaScript code. But you can have a function, and you can grab a hold of a browser tab, and you can, the punchline here is where it executes a script on that tab and just injects code that would then give it access to, so this is from the pop-up script to the content altering script. So by injecting code, it can communicate, so to speak, with the content altering script. Another way is through message passing. So there's send message and on message functions. And this is cleaner and more readable and easy to work with. And you can just pass messages between these different components. And then finally, there's the way that I did it, which is messing around with local storage. Turns out local storage is an easy conduit for communication because all these different elements have access to local storage. So why wouldn't you? So while I can't, like from the pop-up script, I can't get a direct handle to the content script or, functions or the this of the content script, I can coordinate by using local storage between them, effectively, destroying that wall that's supposed to exist between them. And that's what I did in my example. So in the pop-up, when I click the checkbox, it writes that to local storage, and then the content altering script detects that change in local storage and reacts accordingly. All right, so building and deploying is pretty straightforward. As it turns out, it's just like WebEx build, and it'll create 2 packages if you set it up for both Chrome and Firefox. And it turns out it's really easy to publish something on the store. With Firefox, it's all data. Like you just have to give it information. You have to give it an email address and confirm your email address. Pretty straightforward. With Chrome, you have to pony up $5. I guess they want some like low bar to entry, but that is literally all you have to do. And then from that point on, you can publish browser extensions to their stores. So relatively low bar. And where you end up is this, which is, as I said at the start, my intention the very first time I did this was to publish it live. It did take a few hours, but eventually they both got listed. And interestingly, last year I went to do this talk again, and I noticed that it wasn't publicly listed on the Firefox store anymore. Like it had been taken down. And I'm sure I got a bunch of emails that I didn't see. But it turns out Mozilla had some questions about what I was doing. And I was like, all right, this is what I was looking for. Somebody to say, hey, why do you want all these permissions for this? If you're showing cat GIFs, why do you need access to all the websites that the user's visiting, for instance? But it turns out that wasn't Mozilla's question at all. Their question or why they delisted it was because Mozilla requires that if you use a third-party library, this is a minified version of the browser polyfill. So when you're looking at a minified JavaScript, there's, oftentimes hard to get information about what it is. And so when you use a third-party library, you're supposed to include in your web extension, your browser extension submission form, references like to a GitHub repo or like where this minified thing lives, and ideally proof of that this asset was produced from that GitHub repo, like a hash or something like that. The thing that made me laugh about that is that this is Mozilla's library. I was using their library and they were flagging it as like a third-party library. So once I provided them with the necessary documentation, which was like a paragraph saying, hey, this is your library, this is what allowed me to publish this on the Chrome Web Store, then they relisted it. But they didn't have any security questions for me, as it turned out. So I thought that was interesting, as a process. And really, my intention is not to like throw shade on Google or on Firefox. Like these are tools that we all use every day, but managing these kind of things in a secure way is super hard. If you look at the Apple App Store and the Google Play Store, they're constantly dealing with malware and bots and duplicates and resubmissions and to a greater or lesser degree, they're delisting stuff and having to deal with that all the time. So it's not a trivial problem, but I will say I would have expected some sort of deeper scrutiny when I'm asking for the broadest possible permissions that exist in browser extensions. So the whole punchline of this is, as developers, as security professionals, whatever different hats we wear, we do need to be a little bit discerning about what we're loading into our browser, because the browsers, since the late 90s have gone through these evolutions to sandboxize things. That's not really a word, but I just made stand up, to keep things safe. We introduced core, so, you couldn't have these cross-site scripting attacks. And we've gone a long way to make the browsers more secure. And this capability of browser extensions kind of does a neat end run around all that. Like the sandbox, I have access to all of it. And I can change the content and I can do all kinds of things. So now, as I understand it, and maybe somebody here knows more about this than I do, I need to freshen this up a little. But I at one of the conferences I was at, I had somebody actually on the Microsoft Edge team attend my talk, and he said, by the way, one of the reasons that Microsoft kind of adopted Chromium and built Edge is because they want to make this better. And they're adding kind of the stuff that we see everywhere else in other contexts, except for browser extensions, like making sure that things are cryptographically signed so that you trust them, and having a more robust process. I haven't looked at Microsoft's store specifically for Edge, but supposedly they're trying to make things better. Like Microsoft, or at least this person at the talk, acknowledged that, like, they're aware that this is a problem, and it's kind of one that isn't often talked about. And there are browser extensions that do like serious stuff, like 1Password. That's kind of like the keys to my little kingdom. If that were compromised in some way through, some kind of weird backdoor through the browser extension, that would be really bad. So that's the show. This QR code gets you to a GitHub repo that has this slide deck, and it has the browser extension itself is open source. It's just sitting there in my GitHub account. And so, you can play with WebEx and play around with this stuff if you want. I'll leave that up for a minute. But that's it. Any questions about browser extensions and how they can completely pollute and destroy your computer?
How did you get to that the extension console?
Oh, good question. Did I actually? Yeah. Oh no. This is just the listings, and I do this infrequently enough that I kind of forget.
Because the regular console is just F12.
Right. Oh, I know. Yeah. So over here, I'll show you. I actually have my little cheat sheet because I never remember. It's here's how you do it for the different browsers. In Firefox, you go to the hamburger, you type on add-ons and themes, you go to the gear, you debug add-ons, and you click inspect. Right? Totally intuitive. That's why I had to make notes, because it's not totally intuitive. For Chrome, you do the 3 dots, more tools, extensions, then developer mode and background page. And I can show you what that looks like for each of these. Is this the one? No, hold on. Different window. Not you. Oh, it's this one, I think. Yes. So it's hamburger, add-ons and themes. Then there's a gear icon, and then debug add-ons, and then inspect. So basically you want to get here where it shows you the add-ons, and then when you click on inspect, it brings up this in a separate tab. In Chrome, it's a little bit different. It's dots, more tools, extensions. And then you have to make sure by default this developer mode is not switched on. So you switch on developer mode, and then when you do that, you have a link to the background page, and clicking that background page is what brings up this extension console. Make sense?
Mm-hmm.
All right, cool. Well, awesome. Thanks for coming, everybody. Appreciate it. Yeah. And, please do let me know if you know of anybody that would like to give a talk, or if you would like to talk. It's a very very diverse subject. So Branson, in our first one, he was talking about social engineering, had a lot of great stories. So, you know, anything security direct or security adjacent is welcome. And the other thing that I wanted to show you all is DevSecCon. So DevSecCon 24 is our annual event. It's free. We basically do a full day in these different areas of the world. So APJ, Europe, and America. I'll be co-hosting the Americas segment, and you know, we have a lot of good speakers from all over. And it's I went last year for the first time, and it was, you know, I'm a little biased, but it was a high quality event. It looks like it's June 14th. So I'll be sending out other tweets and messages on the meetup page, but that's going to be the meeting for June. And then we'll come back here in person fourth Wednesday of July. So I'll leave that up, and I don't know if anybody wants to take one of the boxes home with them. You're welcome. I think there's still plenty of food there. I scaled it down from last time.
Yeah, last time it was like 6 of us went home with a box, I think.
Yeah, I think we each had a box. You know, I wanted to, you know, shoot for the moon. Hope there'd be a lot of people, and you know, there will be. We're growing. But this is kind of I don't know, I think it's among the first, if not the first, local sort of meetup that's back to in person, right? So maybe I'll inspire .net to go back in person too.
.net, there was a Docker meetup as well.
And there's 757 Python, right? Isn't that local? I don't know if they
they're still
meet in person.
virtual.
Yeah. Yeah. All right, cool. Let me end the live stream, and then go about our days. Well, this setup worked really well tonight, I thought.